Hi, welcome to the video guys. My name is Pushpinder Gill and today we are going to do counting 4, right? So in counting 4 we will be discussing several different kind of question which we have not done in the 3 parts of counting, right? So for people who don't know what counting is, it's the same as your topic called permutation and combinations. Logically we call it counting, fine. So logically we call it counting, so that's the word. So before we start guys, this would be the web address. Lot of exciting stuff now. Used to be an old website long time back, but now there are lots of exciting stuff on this website. Then this would be our Facebook page. Don't give us your valuable like, and don't forget to subscribe as well to our YouTube channel. And this would be the web address where you can give me your feedback. Fine. So moving forward guys, so today we're going to do a different kind of a concept. When there are a group of people, and a subgroup within that group of people is tied together, then how do you do these kind of questions, right? So there is a group of people. Let's suppose that there are 6 boys, fine, and let's say 3 boys want to be together all the time in a line. So 6 boys want to stand in a line, and there are 3 particular boys who always want to stand in the group. So here are the steps which are involved to tackle questions like these. First of all is separate the groups, right? So what you do is you kind of separate the groups, fine. You separate the groups. Now over here you have 2 kind of groups. You have these 3 boys and you have another 3 boys as well, right? So you got a group of 6 boys, and within the 6 boys there are 3 boys who want to stand together. So you got to separate these groups. Then you count how many different individuals do you have. So you have these 3 boys, boy 1, boy 2 and boy 3, and you have a group of 3 boys here which wants to come together, right? So this group will always have to be together. So indirectly you have 1, 2, 3 and 4 groups, right? So what you do is you count how many groups do you have. You have a total of 4 different people who can be arranged anywhere. So in how many ways can 4 people be arranged in 4 ways? That would be 4 factorial, because if you watch the video permutation 1 and 2, you would know that in how many ways can 4 people be arranged in 4 spaces. That would be 4 factorial ways. Now then what you do is you kind of arrange them within the group as well. Now what do you mean by arranging them within the group? Now in how many ways can this boy 4, boy 5 and boy 6 can arrange themselves? Now these guys can arrange themselves in 3 factorial ways, because these 3 guys, they can come anywhere, right? So one arrangement would be boy 1 and you have your group, and boy 2 and boy 3. Now this can arrange in 6 ways, because boy 4, boy 5 and boy 6 can arrange in any number of ways. That is 6 different ways. So that means your overall factorial, that means your overall arrangement is multiplied by the number of arrangements that it is multiplied with, right? So I suppose you're understanding what I'm trying to say here. So basically if I talk about generalizing this, just a second. If I talk about generalizing this, you arrange the groups. So you arrange the groups into, you arrange the subgroups, fine. So this is how you glue people together in a line or in an arrangement. Let's see some questions on that so that it becomes a little bit more clear to you. So there are 6 chairs in a row. In how many ways 4 boys and 2 girls sit together such that all the 4 boys are always together? So I have these 4 boys, boy 1, boy 2, boy 3, boy 4, and there are 2 girls. Now these 4 boys have to be together. So we tie them with a rope. So how many groups do we have? 1, 2 and 3. Now these 3 groups can arrange in 3 factorial ways. But I have to take care of these boys as well. These boys can be arranged in 4 factorial ways. These boys within themselves can be arranged in 4 factorial ways. If I break it down for you, how did this 3 factorial come? I have 3 slots. First, any of the 3 groups can come. Then any of the 2 groups can come. And the last group has to come there and then. Then for these both 4 boys, I have 4 slots. Then any of the 4 guys can come. Any of the 3, any of the 2 and any of the 1. Fine. So suppose you're understanding what I'm trying to say here. This is how you arrange people together in a group. So we'll do a lot of questions on this, but before we do it, there is another type of question when the group does not want to come together. Let's see it in a form of a question. There are 6 chairs in a row. In how many ways can 4 boys and 2 girls sit together such that no 2 girls are together? So what you do in this, the steps over here in this kind of question is to arrange the bigger group first. So what do? You arrange the larger group, not the bigger group, the larger group, the group with more people. So what we're going to do is we're going to arrange the boys first. In how many ways can these boys be arranged? These boys can be arranged in 4 factorial ways. Then what you do is you count the number of spaces in which the girls can come. So you have boy 1, boy 2, boy 3 and boy 4. Now, in how many spaces can these 2 girls come? There is 1 space here, 2, 3, 4 and 5. So 1, 2, 3, 4 and 5. In these 5 spaces, these 2 girls can come. So how many slots do I have? I have 2 slots. So first girl can sit in any 5 spaces. Second girl can sit in any 4 spaces. This is indirectly 5p2. So I suppose you're understanding what I'm trying to say here. First you arrange the larger group, you arrange the number of boys, then you kind of lay them down and find how many positions are there for the girls to sit. So we had 5 positions. In those 5 positions, 2 girls had to sit. So again, if you go by the slot method, first you're going to draw 2 slots, always draw the lesser number of slots. Then see how many ways any 5 can come here, how many ways any 4 can come here. Right? So that would be the number of ways 4 boys and 2 girls can sit such that no 2 girls are together. So suppose you're understanding what I'm trying to say here, guys. Let's do a lot of questions on this, right? So that it becomes a little bit more clear to you. Now, if this question says that how many ways general can be arranged such that all the vowels are together. So you have G, E, N, E, R, A, L. So this is not a vowel, this is a vowel, this is not a vowel, this is a vowel, this is not a vowel and this is a vowel. Now all the vowels have to be together. So you have 2 different groups. You have E, E and A. That's one group which has to come together. Then you have G, N, R and L. So basically you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm just verifying that I've not missed any of the word. So how many ways will you arrange 1, 2, 3, 4 and the 5th group all together? You'll be arranging this in 5 factorial ways. Right? So you would be arranging this whole group in 5 factorial ways. And how many ways would you arrange the subgroup? That would be arranged in 3 factorial ways. However, if we see that E is repeated 2 times, which is why we will divide it by 2 factorial. Fine, guys. Now the question must be looking very simple to you. You got to break it into parts. You got to bring out all the the groups which don't have any condition on it and the groups which have condition on it. Arrange the groups first, then arrange the subgroups, and then just make sure that there are no repetitions. If there are repetitions, you divide by the number of factorial to remove that redundancy. Fine. So I hope you watched the permutation and combination second part video where I specifically explain in detail why this 2 factorial came. Fine, guys. I suppose you're understanding this point here. Moving forward to the next question. So I would like you to pause this video and try out this question for yourself because it has answer options as well. Okay. So in how many ways can the letter of the word numbers be arranged such that vowels are in alternate position? Fine. So when I say alternate position, that means the vowels don't appear together. That's one thing. But again, there is another condition that they are in alternate positions, which means they come after each other after one position. So how many vowels are there? There is U and then there is E. So this is a vowel which is there. So you're going to have 2 groups. You're going to have a group of N, M, B, R and S. And you're going to have a group of U and E. And there is going to be one person between U and E. Fine, I don't know which person is that. So there's going to be one person between U and E, and this is one group. Fine. So if I put one person between U and E, that means one out of them is going to get eliminated. Let's say the S gets eliminated, which means this is a group of 4 and this is a single group. So in how many ways can this group be arranged? So you have 1, 2, 3, 4, and then you have this whole fifth group. That means this can be arranged in total number of 5 factorial ways, right? So this over here can be arranged in a total number of 5 factorial ways, because you have 1, 2, 3, 4, and some of the guy has to come here, and this is the whole fifth group, which can be arranged in 5 factorial ways. Now, in how many ways will I be able to put a number here, right? So that is possible in 4 different ways. I suppose you're understanding this point. I can put a number here in you can put a number here in 5 different ways. You have N, M, B, R, or S. Any of the 5 numbers can come here. Now again, you got to take care of one thing. What is that one thing? This U and E can replace itself like this. You know, it can be U slash E, it can be E slash U. That means I've got to multiply by 2 to take care of this repetition. Which is why my answer is 10 into 120, which is equal to 1200. This over here is my answer. So suppose you're trying to understand, you're understanding what I'm saying here. You have 2 groups, and there has to be one guy between U and E. So the one guy comes here. So I have a space, I have a slot between U and E. So I've got these 5 people, and I've got these 2 people. But out of these 5 people, one guy has to come here. And how many ways can he come? Is 5 different ways. Then how many ways these groups can be arranged? 1, 2, 3, 4, and then this whole fifth group, that is 5 factorial. But this U and E can replace itself in 2 different ways, which is why into 2, that is why my answer is equal to 1200. So suppose you're understanding what I'm trying to say here, guys. Moving forward to the next question. Alright guys, let's go ahead and see this question. It says that 5 men and 4 women are to be seated on 9 adjacent seats in a cinema hall in such a way no 2 women sit together. So you have 5 men and you have 4 women, right? So again, it's a way of arranging them separately. So what do? Is we arrange a bigger group first. So that can be arranged in 5 factorial ways. So I'm going to have M1, M2, M3, M4 and M5. Now someone can come here, 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 here and here and here. So how many spaces do I have? I have 1, 2, 3, 4, 5 and 6 spaces. In these 6 spaces, how many women do I have to fit? I have to fit 4 women. That can be done in 6p4 ways. So my answer is going to be 5 factorial into 4 spaces. I have 4 slots. In the first slot, first woman can sit in any 6 spaces, second woman in any 5, third woman in any 3, and this in any 3, which means this over here is going to be my answer. So suppose you're trying to understand what I'm trying to say here. First arrange the bigger group in 5 factorial ways. Then it says that there are 4 women, and then there are there are 9 seats. The total number of seats are equal, which means these 5 people, they have 6 seats wherein 4 women can sit, which can be arranged in 6p4 ways, or understanding in a slot way. I have 4 slots, then I have 6, 5, 4, 3. So that over here is going to be my answer. So suppose everyone is understanding what I'm trying to say here, guys. Moving forward to the next question. It says that arranging the letters of the word discussion. What is the probability all the vowels are not together? So he says that what is the probability that all the vowels are not together? That would be 1 minus the probability all the vowels are together. Fine. So that's pretty simple to do that. So now all the vowels have to be together. So I have D-I-S-C-U-S-S-I-O-N. So how many vowels are there? 1, then I have 2, then I have 3, and then I have 4. D is not a vowel, C is not a vowel, S is not a vowel, and N is not a vowel. So I have D, C, S, S, N, and I have I, U, I, O. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm missing one word here. D, S, C. So I've got one more S. See, it's very important to verify it this way. So I've got D, S, C, S, S, N, and I, O, U, I, O. So gotta make all the vowels together. So how many different words are there? So there's 1, 2, 3, 4, 5, 6, and 7. In how many ways these 7 guys can arrange themselves? 7 factorial ways. And how many ways can these 4 guys arrange themselves? That is in 4 factorial ways. but I'm not gonna take care of the repetitions. So S and S repeats 3 times, which is why it will get divided by 3 factorial. And D does not repeat at all, and I repeats 2 times, which is why this is 2 factorial. And C does not repeat at all, U does not repeat at all, O does not repeat, N does not repeat. So which is why this is the number of ways in which this can be arranged such that all the vowels are together. Now I've got to find the total number of ways. The total number of ways everything can be arranged, right? So the total number of ways everything can be arranged would be equal to, so I've got to find the total number of ways. That would be equal to, so I've got how many words? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 words which can be arranged in 10 factorial ways. But again, this 3 factorial and 2 factorial will divide, which means when I say 1 minus the total number of ways divided by my favorable ways divided by the total number of ways, this and this is going to eventually cut each other, which means I have this as my answer, which is going to be equal to 1 minus. So the 7 factorial is going to give 8 into 9 into 10 here. So I'm going to have 4 factorial, which is 4 into 3 into 2 divided by 8 into 9 into 10. So I'm going to have 4 times 2 as 8 and 1 times 3 as 3. So it is going to be equal to 1 minus 1 by 30, which is going to be equal to 29 by 30. So that over here is going to be my answer. I suppose everyone is understanding what I'm trying to say here, guys. It says that arranging the letters of the word discussion, what is the probability that all the vowels are not together? So what do I do is I make all the vowels together. So how do I make all the vowels together? It's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 and the 7th, which can be arranged in 7 factorial ways. But this itself can be arranged in 4 factorial ways. Now this I can repeat itself in 2 factorial ways, which came here. And this S can repeat itself in 3 factorial ways, which is going to come here. Similarly, the total number of ways are 10 factorial by 3 factorial into 2 factorial ways. And then I have this, and I just solved it up, then it's going to be my answer. Fine. Now that is there. Moving forward to the next question, guys. Alright, so next question. So thank you very much for watching this video, guys. I suppose now it's clear to you how to solve these questions when you have to glue things together or to take them alternatively, is to divide them into groups and then make sure that you take care of every type of thing that will hamper your answer or will change your answer or will not apply the logic straight away. So there would be a lot of ifs and buts that you have to take care in every question, but I've given you a structure to solve these kind of questions. So this would be the web address. A lot of exciting stuff here, guys. This would be the Facebook page to like us, and this would be the web email address where you can send me your valuable feedback. And if you are enrolled in our GMAT math self prep, then don't forget to practice from the practice portal, right? So that would be about this video, guys. Thank you very much, and I'll be seeing you in the next one. Cheers.